The Haber process is a classic exam question, and they're always asking you to explain why the chosen conditions are 450 degrees C and 200 atmospheres. So I've written out a textbook answer to this question here. So learn this off by heart, and whenever this question comes up in the exam, just regurgitate it and you'll get full marks for this question. So first thing to do is write out the Haber process equation at the top of the paper. So it's N2 plus 3H2, and use the correct double arrow symbol, goes to 2NH3. This double arrow means it's a reversible reaction. So it can go in the forward direction, but the ammonia that's formed can decompose and go back into nitrogen and hydrogen. Okay. In the forward direction, it's exothermic. And in the backward direction, it's endothermic. Exothermic meaning heat is released in the forward direction and heat is taken in the reverse direction. Okay, so get that down on the page first. Now, firstly, write the reaction is reversible. Okay, don't write the numbers, just write all this in nice neat sentences, but pretty much word for word. Okay, then talk about temperature first. The forward reaction is exothermic, so decreasing the temperature increases yield. Okay, we'll talk about the reasons for this at the end, but just commit that to memory, regurgitate it word for word. So these two are the temperature things, they're connected. Then say, however, decreasing the temperature also decreases the reaction rate. Okay. And now we've dealt with temperature. Then these two are the pressure. There are 4 molecules on the left, but 2 on the right. So increasing the pressure increases yield. However, high pressures are expensive to achieve. Okay? And now you've dealt with pressure. And finish it all off by saying the chosen conditions are a compromise between yield, reaction rate, and cost. Done. Full marks. Use the word compromise, okay? They love that. And it's a compromise. So, that's it. That is exactly why the Haber process, the conditions chosen are a compromise between yield, reaction rate and cost. So, if you're interested in the actual reasons why these are true, okay? At GCSE in Britain, for some reason, they don't expect you to know the name of the principle, but it's called after a guy called Le Chatelier. It's Chateliers Principle. And I think they should teach you because it can help you remember. It works like this, okay? Simply put, Chateliers Principle says that whatever you do to a reversible reaction, it will do the opposite, right? So, if you try and increase the temperature, according to Chateliers' principle, the reaction will shift the equilibrium by trying to decrease the temperature, right? So, if we try and increase the temperature, that means we're putting more heat in, okay? Now, it's already exothermic in that direction, so the reaction will try and do the opposite. It's exothermic in that direction, and we're trying to put more heat in, so it does the opposite. It tries to decrease temperature, decrease heat. And because it's exothermic in that direction, it's endothermic in that direction, so it will shift the position of equilibrium in the endothermic direction. Okay, so therefore, according to Chateliers' principle, if we try and increase temperature, it will shift the equilibrium in the endothermic direction. And so if we're trying to make this stuff, it will decrease the yield. Okay? I'll just go through that again. Whatever we try and do to the reaction, it will shift the equilibrium to do the opposite. So if we increase temperature, it will try and decrease temperature, and it does that by moving it in the endothermic direction. Okay? And that's why, if we're trying to make ammonia, if it's moving in that direction, it decreases the yield. So decreasing temperature increases yield, increasing the temperature sends it in that direction and decreases the yield. And it's the same for pressure. Chateliers Principle explains this. Okay, there's 4 molecules on the left, 1 nitrogen, 3 hydrogens, and 2 on the right, 2 ammonias. Okay, so in other words, there's twice as many moles on the left as there are on the right. In other words, there are twice as many molecules on the left as there are on the right. So, if we try and increase the pressure, okay, Chateliers Principle, it will shift equilibrium to do the opposite. It will try and decrease the pressure. So, because there are more molecules on the left, if we're trying to increase the pressure, it will send the equilibrium to the right, where there are fewer molecules. Because think of it as fewer molecules, less pressure. Okay? I'll just go through that again. If we try and increase the pressure, the equilibrium will shift to do the opposite. The reaction will try and decrease the pressure. And decreasing the pressure means going in the fewer molecules direction. And there are fewer molecules on this side than there are on that side. Okay? So that's why if you increase the pressure, the yield will also increase, because if we try and increase the pressure, it will move to the fewer molecules direction, which is this side. So increasing the pressure increases yield. Like I say, GCSE level in Britain at least, you don't need to know that it's called Chateliers Principle. But for some weird reason, you do need to know how it works. And that's how it works. Okay? So, to summarise, just commit that to memory and regurgitate it in the exam and you'll get full marks.